Welcome to the video of Chapter 5, Lesson 6, ASA and AAS. By the end of this lesson, we will figure out how to use these tests for triangle congruence. First, let's get a little vocabulary in this example. Side BC is called the included side of angle B and angle C. This is very similar to the included angle we had in the last lesson with side, angle, side. So it has to be between these two angles, and notice the letter matchup. So BC, this side, is the included side between angle B and angle C. So without even looking at the picture, we can say that side AC is in the included side of angle A and angle C. That if AB is the included side, then it's between angle A and angle B. And again, I answered that without even looking or referencing this picture down here, simply looking at the letters. If I reference the picture, AC is over here, this side is in between angle A and angle C. Side AB is the included side between angle A and angle B. So let's talk about the ASA postulate. If two angles and the included side of one triangle are congruent to corresponding angles and included side of another triangle, then the triangles are congruent. So the ASA stands for angle, side, angle. So let's compare these two triangles here. So we're going to start with this first part of the statement at least. This is triangle BMW. So triangle BMW. So one arc, no arc, two arcs, but notice that it has two angles and an included side that's marked congruent to these two angles and this included side. So all we really have to do here is focus on the way that the order of the letters, just like we have had to do in previous lessons. So BMW, so a single arc matches the C with this single arc. Then it went to M, which is no arc, so that's going to be R in the second triangle, and then V is what's left with the two arches like W and V match up. And because it is the two angles and this included side here, then it's congruent by angle, side, angle. Hopefully you're getting the hang of these congruence tests so far. This will be the fourth one that we're going to be talking about, and it's AAS. So this states that if two angles and the non-included side of one triangle are congruent to the two corresponding angles and the non-included side of another triangle, then the triangles are congruent. So I was stressing the non part of it because this is the first postulate where we are looking at something that's not included. So let's take a look at this example down here. So we have two angles and then we have a side that's not included, and notice its relationship to where the other angles are. So we can't have this one labeled as congruent to this one over here because it's not matching the location or its relationship with its angles as far as corresponding sides. So in this case, this side TX would be the included side, but we're looking for the non-included. So angle, angle, side, angle, angle, side. So we have no letters to start from here, so we're just going to go ahead and pick whichever way we want to go with it. I'll start with T simply because it has the one arc, and then I'm going to go to X because it has the two. So TXU, and then referencing the second triangle, R is the one that has a single arc, M has two, and then that leaves E. And so this is congruent, these triangles are congruent by angle, angle, side, because that's the relationship that they have for congruency. All right, this example asks us to write a congruent statement for each pair of triangles, and the tricky part about this, again, just like in previous lessons, is really figuring out how everything matches up and what letters are in which triangle, because there's a lot going on here. So I'm going to start with the sides, because the sides are just easier for me to start with. So I'm just going to draw a random side. This is going to be GU, and then in a second triangle, similar NK, and these are congruent, so I'm going to go ahead and mark them with congruence. Now, the next piece of information is an angle relationship. Well, angle G. Well, if I look here, I don't have an angle yet. I just have a side. So I'm just going to draw anything, and I don't know specifically what this letter is yet. I just know that I have an angle that's congruent to an angle N over here. So I have to also draw that angle on that side. Then my next piece is angle S to angle O. Well, where's S? I don't have an S. But in order to make a triangle, the S has to be here. So angle S over on this one, and same thing with O on this triangle. I don't have an angle O, so it has to be that third vertex right there. And those are congruent, so I labeled them with 2 arches. So if we look at the relationship, I have 2 angles and a non-included side, 2 angles and the same non-included side. So this is the same one because I know it's the same one from starting with this statement up here. The corresponding when I say the same one. So what our congruent statement will be is that triangle GSU is congruent to triangle NOK by angle, side. When you are given all side congruencies, I think this is the easiest one to draw because it certainly sets things up fairly straightforward. So side ZE is going to be congruent to side ML. So random sides marked with congruency. WZ, okay, well W to Z, so notice how I started out there. WZ and then I to M, so label that with an I and congruence. And the last one, EW, is congruent to LI. And if we remember from the previous lesson, these triangles, triangle ZEW, is congruent to triangle MLI by side. Oops, side. So not from this particular lesson, but still it's a test for congruency. If all 3 corresponding sides are congruent, then the triangles are congruent by side. The first piece of information in this particular problem is an angle relationship. I'm going to skip that and start with the sides. So AT is congruent to DB, and then TO, so over here, TO is congruent to BH. And then I'm going to go ahead and finish off my triangles, not with any congruency because I'm not given that relationship. I'm given the relationship with the angles. So angle T is congruent to angle B. So looking at our information here, now I have 2 sides and an included angle. 2 sides and the same included angle. Remember that nose between the whiskers. Same nose between the same whiskers. So we have triangle ATO is congruent to triangle DBH by side, angle, side. So this one gives us the triangles already. It says that in triangle KRG and triangle JMS. And what you have to realize here is that this is not a congruence statement. So I cannot use the order of these and just assume that K and J are the same or R and M are the same and so forth. I cannot do that because this does not say congruence here. It just says I have 2 random triangles. So if I wanted to, I could just start with the 2 random triangles. This is in no way, oops, I'm using the wrong letters here. This is in no way saying that this is the order that they match up. So now I'm going to go ahead and label the congruency with the information that's given. So angle G and angle J are the same. So angle G and J get 1 tick mark or 1 arch. GR, side GR is the same as JM, okay, so right there. So I labeled them with the 1 tick mark. And then angle R is congruent to angle M. So angle R up top with 2 arches, angle M with 2 as well. So it almost looks like the transformation that happened here might actually be a reflection. Remember we talked about that in the geometry and motion lesson. So it looks like a reflection there. That's the transformation, but that's not the actual congruence relationship. So we don't want to get caught up in that too much. So triangle KRG is congruent to triangle SMJ. So since I started with K out here that has no congruency, KRG, then I have to start out with SMJ. So the order has to match up here. And notice it does not match what was given in the original statement. So please understand again that this did not give congruency. It just said that I have 2 triangles. Okay, but they are congruent by Well, let's see here. We've got two angles and an included side. Two angles and the included side, that same included side. So this is angle, side, angle. I talked a little bit about these sort of problems in the last lesson, and so it was just a little bit of a preview for what we're going to be talking about here. It says, for each pair of triangles, name another condition necessary to show that they are congruent. So for example, if you just have two sides that are congruent, that's not enough information to say that the triangles themselves are actually congruent. So you can use side, 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 but we would need another condition to be true. And in order to get all three sides congruent, to use this congruency test, well then side FH would have to be congruent to, so FH is coming off of the double side, so F is coming off of the double, so I'd have to reference that with P, C. So that's what would have to be congruent in order to use side, side, side. But the other congruency test that also has two sides congruent is the side angle side. It just has to be that included angle in between the congruent sides. So we would need angle J to be congruent to angle G. So a reminder that as is, these original triangles do not have enough information to state that the triangles are actually congruent. But if we wanted to use side, 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 these two sides would have to be congruent. Or if we wanted to use side, angle, side, then those two angles would have to be congruent. So again, taking a look at these two triangles, I have a congruent side and one congruent angle. If I wanted to use side, angle, side, then the angle would have to be included in between the congruent sides. So that means that this have to be this congruent side, this angle, and then that nose between the whiskers, we need that other set of whiskers. For angle, side, angle, then it would be the angle, then the side would be included, and we would need that other angle. So go ahead and figure out what the relationships would actually need to be, what we would need to have congruent to use these two tests. Hopefully you got similar answers here. In order to use side, angle, side, SD would have to be similar or congruent to TP, and in that order, if you wrote DS, then it would have to be PT. And then the angle that would need to be congruent to use angle, side, angle would be angle A and angle L. Last one, in our set of triangles that we have here, we've got two angles that are marked as congruent. So those choices are either angle, side, angle, or angle, angle, side. Remember that this side would need to be included. This side would have to be the same, the corresponding non-included side. So go ahead and see if you can come up with the correct sides relationships there. So the only way to get your included side in there is that it has to be this long side here included in between these two angles. You just want to make sure you're careful with your order of your letters. If I say YQ, then it has to be BC because Y and B are marked with the same congruency and C and Q are marked with the same congruency. So you want to make sure you're careful with that. When we look at the angle, angle, side, we actually have two choices for that non-included side, but it's important that you're picking the matching non-included side. So if I say RQ, then notice that that's the one that's touching the two arch angle. So over here, it has to be VC for that congruency. The other non-included side that you could pick could be RY. RY is the non-included side that's touching the single arc, so RY would have to be congruent to VB. You don't need both of those things to happen in order to use AAS. You just need one of them to happen. The key here is that you cannot have RQ to VB because those are not the same included, that they're not the matching non-included non-included side. Same thing with this. You can't have VC congruent to RY because they're not the same non-included side. Lastly, we've been using a lot of A's and S's. Why not ASS? Why not angle, side, side? Well, the answer is really already on your notes there. Congruency tests must guarantee that the three sets of conditions produce identical triangles. So if I have an angle and then two sides, like ASS suggests, then what we have here is we are not guaranteeing that that third side has to be the same length, because this side BC that is congruent to EF here, there's no argument with that, but it could be swung in to have an acute angle, it could be swung out to be right, or maybe an obtuse angle even, and we could dictate the length of DF or AC however we want to swing this side BC, however we want to create this angle here. So it has to guarantee that these conditions create identical triangles, which in this example they don't. So ASS does not guarantee identical congruent triangles, so we cannot use that to test congruence. So this concludes lesson 6, angle, angle, side, and angle, side, angle. So we use these congruence tests by getting two angles and an included side, or two angles and the same non-included side congruent, then the triangles are also congruent.